A very good morning to all of you. Welcome back to the sessions on science and technology. First thing first, if the audio and video are fine, please let me know. Okay, wonderful. Now, so we had started with space technology in yesterday's class, and we had started discussions about various celestial bodies, where we discussed about the star and we also discussed about the sun. Now, to move on from there, the next topic that we have is about planets. Now, when it comes to planets, the definition of the planets and all the things related to them also has been very interesting. That when it comes to how to determine whether something is a planet, we see that there are these three conditions that have to be fulfilled. First, that it must orbit a star. Second, it must be big enough to have enough gravity to force it into a spherical shape, just like what we discussed about the star as well, that it gets its spherical shape because of gravity. So same goes here, that it should be big enough to have its own gravity and it should be orbiting around a star. Now for the longest time, these were the only two conditions to be fulfilled if you wanted to classify any celestial body as a star. But then this third criteria was added. This third criteria was added back in 2006. Now, the third criteria says it must be big enough that its gravity cleared away any other object of a similar size near its orbit around the sun. Now, understand this point, that what exactly does it say? This point says that if there is any other celestial body which is near a planet, then in that case, it should not exist near a planet at all. It should either be revolving around the planet, it should become its satellite basically, it should revolve around a planet, or it should not exist. So there must not be anything in the vicinity of a planet, near a planet, which has its own independent orbit around the sun. All right. So for example, if you consider the earth, we have the moon, right? We have the moon and the moon revolves around the earth. Let's say the same moon did not revolve around the earth, but it had its own orbit around the sun. Then in that case, we may not have been able to describe earth as a planet, because moon is not getting affected enough by the gravity of the earth and hence has its own independent orbit. All right, so that is where we would see that then in that case we would not say that earth is a planet. But that's not the case. The moon keeps on revolving around the earth and it does not have an independent orbit around the sun. Now, why did we have to add such a, a criteria altogether? Now, why this was added was because of one new discovery that happened, and this new discovery was Aries. Now, Aries orbits around the sun. All right, so that's where the first criteria is being fulfilled. It is big enough to have a spherical shape, so that also is another criteria being fulfilled. So now these two criteria were being fulfilled by Aries. Then in that case, Aries should have been called as a planet. The discovery of Aries meant that it should have been called as a planet because it was orbiting around the sun. It had big enough size to have a spherical shape, and it was seen to be bigger than Pluto. But it was found near Pluto. It was found near Pluto, seen to be bigger than Pluto, and orbiting around the sun with a spherical shape. So, all those things that any other planet is fulfilling, all those criteria are also being fulfilled by Aries. Then, in that case, there were discussions that now Aries could become the 10th planet. Until now, we knew about 9 planets, including Pluto back then. So, Aries would have become the 10th planet. Now, this is where uh, the scientists said, or scientists you can say felt, that the number of planets in this solar system should remain, you can say in a manner, an exclusive club. that there should not be new entrant all the time. Tomorrow another discovery will happen, then you will add another planet to the list of planets. Then again maybe some other planet will be discovered and you will add that to the list as well. So let's not do that. And this is where they've put up a new criteria, that if there are two bodies which are near each other and have independent orbits around the sun, then in that case we would not call them as a planet. And this is where Pluto lost its planethood. So now Aries and Pluto, they both became dwarf planet. They both became dwarf planets. Dwarf planets basically by definition are celestial bodies, celestial bodies that fulfill the first two criteria, but not the third. All right. So the celestial bodies that fulfill the first two criteria but not the third, they are now called as dwarf planets. So then Pluto was reclassified as a dwarf planet because, and just remember that more than the fact that Aries revolves around the sun and it has a spherical shape, one of the biggest contributing factor to all these changes were the fact that Aries was seen to be bigger than Pluto. All right, it was observed to be bigger than Pluto. So then it was said that if Pluto is being called as a planet, then Aries should also be called as a planet. And then they thought otherwise that let's also exclude Pluto out of the planet system and call it as a dwarf planet. Unfortunately, uh, there was a Voyager 2 mission that was sent later, I think 2015, and this is when it was discovered that Pluto is actually bigger than Aries. So the initial observation were wrong. The initial observations were wrong, and you can say in a manner Pluto lost its planethood for nothing. So unfortunate state for Pluto that we see that there are uh, these kind of news that keeps on coming all the time, that no more planets to be discovered in our solar system. We are expanding our future search. These kind of things keep on coming, but Pluto is still not being considered for a wrong observation that was made. It's, you can say, a kind of a humiliation that we had long observations and we made an entire theory about a set of criteria, etc., about that wrong observation. So Pluto is still waiting. There are people who are also still waiting. If you go to Instagram and just type the hashtag justice for Pluto, you will find posts where people are fighting for justice for Pluto. That for all the wrongs that was done to Pluto, there should be something done to get back to the list of planets. So this is what happened. That just the fact that Aries was found near Pluto, seen to be of a similar size than Pluto, even bigger than Pluto, spherical shape, and having its own independent orbit around the sun, not dependent on Pluto. If it was dependent on Pluto, it was revolving around Pluto, then nobody would have said anything. Right. So now, when it comes to these planets, one thing that also becomes important is that sometimes there will be some news about planets in one way or the other, and that can become important for your examination. So that's why you have to be, uh, let's say, in your newspaper articles here and there, small articles might come which talk about something new discovery or some kind of new phenomena observed on a planet. So if that uh, anything like that happens, then in that case I would say that planets might also become an important topic, because again there is a trend that when you look at the number of questions that used to come from celestial bodies earlier, you'll find that a lot of questions used to come until 2010-11. I would say a lot of questions used to come, but then after that, uh, what we have seen is that the number of questions from celestial bodies as a topic has started to decrease. And almost for like almost 8-10 years they did not really ask anything related to celestial bodies, but we have seen that there are questions being asked again. There was a question on the sun in 2022 paper, then questions on nebula and pulsars in 2023 paper. So we have seen that now they have again started asking some questions based on celestial bodies. So maybe this trend continues, and if this trend continues, then topics like these become important, because they used to ask a lot of questions from here, but almost for like 10 years they haven't been asking a lot of questions from planets or celestial bodies as a topic in general. So that's why we have to be aware that these are things that they can start asking again. Now, with regards to the celestial bodies, the next celestial body is a comet. Now, when it comes to a comet, just understand what a comet is. There are three phenomena that we are going to discuss here: comets, asteroids, and meteoroids. So we need to understand what the basic difference between these three terms are. Otherwise, they look very similar to one another. So that's why we need to understand what we mean by a comet, what we mean by an asteroid, and what we mean by a meteoroid. Now, when it comes to a comet, all right, when it comes to a comet, in case of comet, we are saying that it is a cosmic snowball of frozen gases, rock, and dust, roughly of the size of a small town. Now, when we say roughly of the size of a small town, the meaning is that we are talking about, let's say, a radius of 5 to 10 kilometers. All right, 5 to 10 kilometers radius. Now, so they have 5 to 10 kilometers of radius. Now, when it comes to a comet, comet could be made, the main structure of the comet, the center, the core of the comet could be made of some minerals, some metals, etc. And then there will be frozen gases that will be there, dust particles that will be there, and all that will be surrounded by a hydrogen cloud. So in a manner you can say that a comet also has an atmosphere. All right, so in a manner we can say that a comet also has an atmosphere. So it contains dust, ice, carbon dioxide, ammonia, methane, etc. And at the same time you can say that it is surrounded by hydrogen cloud, like atmosphere. All right, so this is what we see, and obviously apart from ice, dust, carbon dioxide, ammonia, methane, etc., the core will be made of metal. Core made of metals and minerals. So this is what we see for a comet. Now, most importantly, when it comes to a comet, the most important property of a comet is this tail, correct? Because what we see is that this is something uh, which is formed because of the dust and the gases. Now, what happens is, as the comet also, just remember this, that comet has a fixed, most of the comets, they have a fixed orbit around the sun, although this orbit will be very large, but they have a fixed orbit around the sun. So now what happens in this case is that when it comes near the sun, this is when some of the frozen gases and dust, etc., they start to form a tail, they start to form a big tail which can go on for millions of kilometers. So this will start to form a big tail, and this tail is something which is pretty much visible. So whenever we look at a comet, we see that comet will be visible with a tail. So this is what we see, and that tail is mainly because of the dust and the frozen gases, because that those frozen gases, as they heat up when they come near the sun, they form the tail. So overall, this is what a comet is. Now, in case of an asteroid, the main difference first and foremost is that an asteroid is very small in size as compared to a comet, because comet, we discussed that it can have 5 to 10 kilometers of radius, whereas in case of an asteroid it will always be less than 1 kilometer, less than 1 kilometer in diameter, I would say. All right, so less than 1 kilometer in diameter. Largely we see that they are in the range of 150, 200 to up to 6, 700 meters in their diameter. So they are very small as compared to comets. All right, so just remember that they can have 150 to approximately 700 meters in diameter. So that's why very small as compared to comets. Also, we are saying that these are small airless worlds. Airless meaning that there is no atmosphere. No atmosphere. So that's why small airless worlds. Now, many a times they are also called as planetoids or also called as minor planets, etc. Largely they are made of some uniformity in material. They could be made of a metal, they could be made of carbon, they could be made of some kind of mineral. So their composition will be anything that a planet's composition could be. A planet's composition, for example, when you consider the earth, so the kinds of metals and minerals that we have inside the earth, the the asteroids might also have the same composition, although there will be a uniformity in their composition, that they'll be made of only something one of the metals. So for example, maybe iron, maybe nickel, maybe something like that. So that's why in case of asteroids we see that there is a uniformity in their composition. All right, now, and the reason why they have this uniformity and why they have a very similar composition to that of the earth is, or let's say for that matter other such planets, is mainly because of the fact that it is believed that the formation of the asteroid might have happened at the time of the solar system formation, and it might have been a planet between Mars and Jupiter, where you have the asteroid belt today. This is where you may have had a planet, and that planet may not have been able to sustain itself and may have broken into several pieces, and these broken several pieces basically today are asteroids. So that's why what we see is that in case of asteroids, we have had a lot of interest in also studying these asteroids, trying to understand these asteroids, because it might give us an insight into the composition of not only the asteroids but maybe also the composition of the earth and other similar planets, and what happened at the origin of the solar system. Better understanding of the origin of the earth, in a manner you can say. Now, we have seen that some of the news related to asteroids have been here and there. So for example, NASA capsule carrying the first asteroid samples lands on the earth. This was 24th September 2023 news. Now in this particular scenario, what we are talking about is uh, an a mission called as Osiris Rex. Now, Osiris-Rex mission is a mission from where already question has come in your prelims examination. Now, when it comes to the Osiris-Rex mission, it went to a carbon-rich asteroid known as Bennu. Right? It it has gone to a carbon-rich asteroid known as Bennu. So what it did is that it went to the surface of Bennu, near the surface of Bennu, and it kicked some particles out of it, collected those particles, and now has come back. All right. So this mission was launched back in 2016, and it was a sample collect and return mission. So that is what it has done, that it has collected the samples from the surface of Bennu, and now it has returned back to the earth. Now, when it comes to this, I mean, there were videos also that were released by NASA. If you go on YouTube and just find Osiris Rex Bennu impact, you'll see that it shows how it just went there, kicked off the particles from there, collected it, and then it has come back. So that's why all these asteroids, they become important, and these kind of missions are there. Apart from that, there are other missions also that have been in the news which are related to asteroids. Sorry, one for example is called as the Lucy mission, and then there is another mission called as Psyche. So these are another missions which have been in the news. So for example, the Lucy mission is about studying Trojan asteroids of Jupiter. Now, what we mean by Trojan asteroids of Jupiter, just hold on for that. We'll have a discussion on what Trojan asteroids are. But just remember that this is a mission for studying Trojan asteroids of Jupiter. And the Psyche mission basically is to study a metallic asteroid. Study a metallic asteroid, and the name of the asteroid itself is Psyche. 16 Psyche is the name of that metallic asteroid. So these are also missions that have been in the news because they have just been launched, and they will be in the news, you can say, up and about in the coming days and years as well. So that's why just remember that these are some of the newer missions on the basis of finding something new from these asteroids. Now, the next topic is about meteors, meteoroids, and meteorites. Now, when it comes to these three phenomena, just understand that all these three terms mean the same thing. All right, they all mean the same thing. The only difference is where are we finding them? What is their location? So, based on their location, these three different terms are defined. The major term is a meteoroid. Now, when it comes to a meteoroid, we are saying that it is a small rock or particle of debris in our solar system, which range in size from the size of dust to up to 10 meters in diameter. So that's why you can understand that they are even smaller as compared to an asteroid. So comets will be the biggest, then comes asteroid, and then comes meteoroid. So just remember that this is uh, the the size magnitude, that is comets, asteroids, and then meteoroids. Now in this particular scenario, they are very small, and then again they are just like stones, you can say very small stones and rocks, etc. Again can be made of metals. Largely we see that they are source of nickel and iron. All right, they contain nickel and iron largely, and there can be other metals also. It's not that it is fixed, but largely they are metal and iron made. Now sorry, nickel and iron made. Now when it comes to these meteoroids, meteoroids do not have a fixed orbit, because in case of a comet also we discussed that they have a very long orbit, because most of them are found beyond Neptune. All right, most of them are found beyond Neptune, so they have a very long orbit. And in case of an asteroid, most of the asteroids are found between Mars and Jupiter. There is an asteroid belt between Mars and Jupiter, and most of the asteroids are found there. Now, in case of a meteoroid, they do not have fixed locations as such, although most of them, again, here they are also found beyond Neptune, but it's not that they have a fixed location as such, just that they can be found anywhere and they do not have a fixed orbit. All right, so that's again some a factor where they are different. Now what may happen is that these meteoroids, which are just freely roaming around in the solar system, sometimes they might, while roaming around, come near the earth. And when they come near the earth, obviously earth has its own gravitational field. So as they come near the earth, this is when they will start getting attracted or pulled towards the earth. So as they get pulled towards the earth, this is where we'll see that they will start falling on the earth, because as soon as they come near the earth, they will be pulled by the earth and they'll start falling on the earth. So while they are falling on the earth, most, you can say 99.9% of these meteoroids, they would completely burn up in the atmosphere, because of the heat that is generated by air resistance in the atmosphere. most of them, as I said, 99.9% of them will completely burn up in the atmosphere. So that's why a meteoroid that burns up as it passes through the Earth's atmosphere is called as a meteor. All right, it is called as a meteor. And then, if let's say it survives the fall, if it completely does not burn up, and in one way or the other it is able to reach the surface of the Earth, maybe only a speck of dust in most of the cases, then in that case it is called as a meteorite. In that case it is called as a meteorite. So that's why a meteoroid that survives the falling through the Earth's atmosphere is called, and it is able to reach the surface of the Earth, then it is called as a meteorite. Now, in case of meteorites, meteorites can also become dangerous. There have been, for example, if you have heard about when it comes to meteors also, you might know that meteors are also called as shooting stars. They're also called as shooting stars. And people also make wishes. Many people believe that if you have seen a shooting star and if you're making a wish, that wish might come true. So same would have happened to the dinosaurs, that they also would have made a lot of wish, and that led to their departure. So what we know is that there is something which is called as mass extinction. There's something called as mass extinction. And one of the mass extinctions that happened on the Earth was because of meteorites. Because a lot of meteorites reached the surface of the Earth. And as they reached the surface of the Earth, the impact with the Earth was huge. Because these were pieces which were bigger pieces. So they were able to reach the surface of the Earth without completely burning up in the atmosphere. And several of these pieces reached the Earth. And at the same time, what it comes to uh, what we basically see is that this impact may have led to a lot of dust and particles, etc., also being ejected out of the surface of the Earth, might have completely covered up a cloud of dust and may have blocked the sun rays for a long period of time. So sun rays being blocked also means that there is no photosynthesis. No photosynthesis means that plants would die. If plants die, a lot of animals which are directly dependent on these plants for their food, they die. The other animals which depend on these animals for their food, they die. So what happened is that almost 85% of the species that lived on the earth back then, they all vanished, including the dinosaurs that were ruling the earth back then. They also vanished along with 85% of all the species of the world. So such a phenomena where you lose so many species together in a short span of time, it is called as mass extinction. I'm sure that you'll hear about mass extinction more in your environment classes, but this is where we see that mass extinction would have been caused by meteor or the meteorites reaching the earth. Because until now there have been five mass extinction. Four of the other mass extinctions have had internal problems, have happened because of internal dynamics of the earth changing, the change in climate, the change in atmospheric conditions, the change in the temperature, etc. In all these cases we have seen that four out of these five mass extinctions have happened largely because of geographical reasons. The only one mass extinction happened because of an external reason, that is uh, external reason that is because of the meteor shower or the meteorites basically reaching the earth. Now the scientists also talk about, the environmentalists also talk about something called as the sixth mass extinction. That, as I told you, that until now there have been five mass extinctions, and now we say that there is a sixth mass extinction ongoing, and this is happening because of anthropogenic nature. Anthropogenic nature, because it has an anthropogenic nature, mainly because of the fact that the way we have been contributing to global warming, to climate change, that is completely changing the way the earth functions. And because of that, a lot of species have been losing their lives, and that's why the extinction rate is increasing. There is and that's why we say that this is equivalent to a sixth mass extinction right now happening on in the world. So anyway, I believe that you will study more about this in your environment classes, but just remember that meteorites have been a reason for a mass extinction uh, on the earth. Read this question. This was asked in your paper. I'm launching the poll for you. Hmm. So what I see is 57% of you have given the correct answer, but there should have been more. But let me just discuss this. What is the difference between asteroids and comets? First is asteroids are small rocky planetoids. This is fine. While comets are formed of frozen gases held together by rocky and metallic material. We discussed about this. Frozen gases, dust, metals, etc. All these being there. So first statement definitely correct. Second statement says asteroids are found mostly between the orbits of Jupiter and Mars. This is okay. While comets are found mostly between Venus and Mercury. This is wrong. What did we discuss? That comets have a very big uh, orbit around the sun, and most of them are found beyond Neptune. Most of them are found beyond Neptune, and that's why they have such a big uh, orbit, right? So that's why this is wrong. Comets show a perceptible glowing tail, while asteroids do not. This is also fine. So that's why correct answer will be B, 1 and 3 only. Now we come to, you can say, the edge of the solar system. After all the planets and all these celestial bodies like meteoroids and comets and asteroids, we see that there is something called as Kuiper belt. Now when it comes to the Kuiper belt, what we see is that this is a region, or you can say a disc shaped region beyond Neptune, that starts beyond Neptune, and a lot of small celestial bodies are found here. A lot of comets are found here, a lot of meteoroids are found here, even some asteroids are also found here, a lot of small dust particles, etc. They all just will remain here in this Kuiper belt. Now, when it comes to the Kuiper belt, we are able to find a lot of smaller celestial bodies here, meaning a lot of smaller celestial bodies are able to exist in this belt, mainly because of the fact that you have come very far away from the sun. And as you can see, it lies around 30 to 55 astronomical units. Do you know what is one astronomical unit? How much is one astronomical unit? Anyone? Any idea? How much is one astronomical unit? Yes. Alinta, you are right. Animesh, you are correct. Hmm. So, yeah, many of you have given the correct answer. It is a total of almost 150 million kilometers, which is basically the distance between the sun and the earth. So that is what one astronomical unit is. So Kuiper belt starts from 30 astronomical units. So we have come 30 times the distance between the sun and the earth. So obviously what happens is that the gravitational influence of the sun is low. Gravitational influence of the sun is low. So that's why a lot of celestial bodies, a lot of smaller celestial bodies are able to exist here. So that's why this Kuiper belt has Pluto, it has all the other dwarf planets, it has a lot of comets, it has a lot of meteoroids, etc. So all these will be found in this Kuiper belt. Now, lastly, the edge of the solar system is defined by something called as the Oort cloud. And as you can see that this is starting from 2000 astronomical units and goes up to 2 lakh astronomical units. So this is basically, you can say, a theoretical shell of icy objects that lie beyond the Kuiper belt. And there are a lot of, you can say, objects of that consist of ices such as water, methane, ethane, carbon monoxide, hydrogen cyanide. All these have been said to be found in this particular area called as the Oort cloud. So Oort cloud, you can say, in a manner, defines the limit of the solar system, defines the limit of our entire solar system. As you can see, that Oort cloud, in a manner, you can say, becomes the no man's land between the two borders. That this is where one solar system ends and another star system might begin. So between the two, you have the Oort cloud. All right, between the two, you have the Oort cloud, and that's why Oort cloud becomes important from this perspective, just that it is something that is defining the distance or the difference between one solar system and the other, right? So now from here, so what we see is that beyond the Oort cloud, the other star systems also exist, and there are missions which have been also targeting the other star systems. Very often, most once in a while, you will come across a news article that would say that certain new planet has been found, or a new planet has been found in another solar system and all that. And all these planets, they are also called as exoplanets. All these planets are called as exoplanets. Exoplanets meaning the planets which are outside the solar system. Planets that are outside the solar system, they are called as exoplanets. So that's why you can say that this is where this all ends. There's one question that actually has been asked in this context. Just read this question. The term Goldilocks zone is often seen in the news in the context of. Now, Goldilocks zone. Goldilocks zone is what they look for when they go outside the solar system. Because Goldilocks zone is the zone where the temperature conditions are moderate. All right. Region around a star where temperature conditions are moderate, making existence of life possible if an exoplanet lies in this region. All right. So around any star, there will be an area where the temperature is neither very high nor very low. It is moderate, just like, for example, on the Earth. So if the temperatures are moderate, and let's say by any chance there is a planet that lies in that region, then chances are that that exoplanet might also support life. So in that context, this question on Goldilocks zone was asked. So now, based on this definition, I'm launching the poll. I'm sure that you'll be able to answer this question. Now, I want 100% correct answers now. 100% correct answers. 99 also will not work. Hmm. I knew that there will be people who will confuse between two options, and that is what has happened. 78% of you have marked C, which is the correct answer. 15% of you have marked A, where there are chances that you can confuse, and rest 3% have marked B and 4% D, meaning that there are 7% in total who are still sleepy. So the correct answer will be C, that we are saying that we are looking for planets where life is possible, where existence of life is possible. So we are looking for Earth like planets in the outer space. So that's why Goldilocks zone is related to that. The first is limit of habitable zone above the surface of the Earth. It's not above the surface of the Earth, it is outside the solar system, not only above the surface of the Earth. So that's why the correct answer will be the search for Earth-like planets, searching exoplanets which lie in the Goldilocks zone, so that survival of any species is possible there. All right. So that's why the correct answer, the most appropriate answer will be C. Now, this brings us to the end of the first section, which is mainly about the universe and the solar system and all these phenomena. Just remember that whatever we have discussed in this first part of our discussion, I would say that this part is largely more important for your prelims examination. Until now, whatever we have seen in this chapter is more important for prelims examination. Now, going forward, we are now stepping into a section which is important for, I would say, both prelims and mains examinations. So that's when now whatever we are doing, I'll also keep telling you whenever I feel, wherever I feel that this is where a question could also come in the mains examination. But just remember that this is how there will be a slight shift in the way we will be looking at things. Now, when it comes to space technology is about harnessing of space, understanding of the space, that how exactly can we go into space, or how exactly can we observe space, and what are the ways in which we can use the space technology, how it is going to be helpful for us in one way or the other. Or is it just about studies, it is just, or is it just about finding out new things, finding out new phenomena, understanding some of the things that we did not know of? Is it just about all these experiments and observations, or is it also something that can have a lot of applications? The answer is the latter, that it does have a lot of applications, and this is also what we will study as a part of this particular section. Now, first thing when it comes to space technology is that how do we even observe? There are two ways in which we can observe the space. One, ground based observations. The second, space based observations. Now when it comes to ground based observations means what? That you are sitting on the ground, you are sitting on the earth, and you are trying to observe the night sky, you're trying to observe the space. So largely you will be using telescopes, correct? This is where telescopes become very, very crucial. And there are various different types of telescopes. There are optical telescopes, radio telescopes, x-ray telescopes, infrared telescopes, microwave telescopes. There are so many different types of telescopes. Although out of all these telescopes, the ones which are the most widely used are the optical telescopes and the radio telescopes. All right, optical telescopes and the radio telescopes. Now why these are the most widely used? Optical telescopes uses visible light. All right, optical telescopes, they use visible light, and as they use visible light, it basically is capturing the visible part of the electromagnetic spectrum. It means that the images that you get out of an optical telescope will be similar to how our eyes also perceives the world. All right, so in a very similar manner, all the images that you will see, you will be able to comprehend better, because all these images will be the images that our eyes could have also seen if we had that capability of seeing things that far. So that's why optical telescopes are the most widely used telescopes. Now, when it comes to the Indian telescopes, there are three major Indian telescopes. One is in Devsthal in Uttarakhand, second one is in Hanle in Ladakh, and the third one is in Javdi Hills in Tamil Nadu. These are the three optical telescopes that India has. Now, out of these three telescopes, the one that we have at Hanle, especially, has been in the news also, and Hanle as a region also has been in the news. So there are optical telescopes and there are radio telescopes. So this, especially the one that we have at Hanle, it has been in the news because of something called as dark sky reserve. Do you know what do we mean by a dark sky reserve? This again has been in the news. Last couple of years it has been in the news. 2022 onwards it has been in the news constantly. Yes, Purva, you are correct. Anyone else who knows? Yeah, Rajneesh, you are correct. Megha, you are correct. Jia, you are correct. Animesh, you are correct. Hmm. So, dark sky reserve basically is an area from where you can watch the night sky, from where you can, uh, with your naked eyes, you would be able to see a lot of stars, and not only the stars, but rather the entire Milky Way galaxy line if you go at the right time. So, so this is called as the dark sky reserve. So now what we are doing is that the government of India is also building a dark sky reserve at Hanle, because Hanle has those kind of geographical and atmospheric conditions that are very well suited for this kind of phenomena, and that's the reason why we also have this telescope right here also at Hanle. So this telescope that you see in the picture, this is a telescope that is in Hanle, and when it comes to this telescope, just understand the reasons that why did we choose this area. Hanle is in Ladakh. You might know that Ladakh is a cold desert area, right? So cold desert area means that there is minimum rainfall. I mean, there are uh, years when we have seen not more than 3 to 4 days of rainfall in a given year. So that's why very less rainfall, almost negligible rainfall, more than 300 days of cloudless skies, which is also phenomenal. So that's why geographically these two become very suitable reasons. Also, the fact that Hanle is very away from any kind of urbanization or any kind of settlement. Even for example, the Leh city in Ladakh is very away, very far away from Hanle, and that's why Hanle, also because of its extreme temperatures, extreme conditions. That if you right now go and check the temperature of Hanle, you might find that the temperature is around minus 15, maybe minus 15, 17 degrees Celsius. So temperatures are drastically low. There are hardly any settlements here. You hardly have any water. Electricity hasn't reached here, so not a lot of tourists come here. So what happens is, given all these factors plus the geographical factor of it being a cold desert and a lot of cloudless skies and almost no rainfall, because of all these reasons together, it becomes a perfect place for observing the night sky. And uh, the kind of views that you can get here is unimaginable, to say the least. It was, I mean, 2022, there was another news about the fact that a research was done about the best places in the world to watch the night sky, and Hanle was around, among those names. So that's why you have to understand that why Hanle was chosen for construction of, or let's say declaration of, a dark sky reserve. So that in a manner it will help in promoting something called as astrotourism. It will help in promoting astrotourism. So that's why this is where people will be able to go and people might be able to watch the night sky. Although getting there is not that easy. I told this in my previous classes also, because I have been to Hanle. I went there almost 2 years back. I went there, and this picture that you see right here, this is a picture that I had clicked. So the copyrights to this picture belongs to me. uh, Now, going to Hanle, I'll tell you how difficult right now it is to go to Hanle. There's only one bus that goes every week. On Saturdays the buses go, on Sundays the buses come back. So, and that's the only one bus that goes there. It takes 350 rupees if you want to go from Leh to Hanle. And if you don't want to go buy a bus and you want to take a cab or something, then you will have to sell some land or sell some assets, and then give them almost, I think they would cost almost around 20,000 rupees for for them to go there and come back. Conditions are extreme. I went in the month of December. uh, the temperatures were of the order of minus 12 to minus 15 degrees Celsius. No electricity, they completely rely on solar energy. So there will be a small LED bulb that will be functional between 6 p.m. to 9 p.m., and after that it's completely dark. No mobile phone network, so you have that peace that you always wanted. So no mobile network, no electricity, no, almost no water available. Extreme conditions, I mean, this bright sunlight that you see, this bright sunlight was minus 10, 12 degrees Celsius. So extremely cold weather. So that's why not easy to reach there, and I hope that it remains like that. I mean, uh, it should remain a place where only if you are really interested enough to go, you should go. Otherwise, uh, if let's say pollution increases, if let's say the movement increases, then you wouldn't have that kind of a view that this place promises. Otherwise, I mean, if you, especially let's say if you are going in these kind of months when the temperatures start to drop and not a lot of people go there, then in that case you'll be able to see views which are unimaginable. Just go and Google the night view from Hanle, and you will understand what I'm saying. So, so that's why, just understand why Hanle and why Hanle has been chosen uh, for this. I went inside this telescope also. They allowed me to go and they showed me around how this telescope works. So anyway, so this is about the optical telescopes. Then we have the radio telescopes. Now, in case of radio telescopes, they would capture the invisible radio waves. Now, radio waves become very, very important because radio waves are the longest electromagnetic waves. And because they are the longest electromagnetic waves, they can travel the farthest. They can travel the longest distances. So, the kinds of observations that radio telescopes can make, no other telescope can do that. Even optical telescopes cannot see that far. They cannot see as far as the radio waves or the radio telescopes can. So that's why radio telescopes also become very widely used, because of that they'll be able to travel longer distances. They can give us results from longer distances. Now, when it comes to India, uh, we have two, one located in Pune and one located in Uti. So the one that you see right here, this is the one that is located in Pune. So radio telescopes will basically try to capture the radio waves, the electromagnetic radio waves, and the observations will be very different. If you look at these two pictures, for example, this will tell you about the difference. For example, this first picture is of an optical telescope, right? It is of an optical telescope. And the second picture that you see right here, this is of a radio telescope. So obviously, when, let's say, if we were observing, if we were seeing it, if we were able to see it, we would see the first picture, right? We would see what the optical telescopes show. We wouldn't see what, I mean, if we are viewing Saturn, we wouldn't see what radio telescopes are showing, because our eyes cannot perceive radio waves. Otherwise, all your mobile phones, internet, Wi-Fi, everything is using uh, radio waves. You would have been able to see those radio waves if our eyes were capable of doing that, but they're not, right? So just remember that this is basically how we look at um, the things with the help of the telescopes. So this is about the ground based observations, where we are using telescopes for getting our observations right. The next is our space based observation, where we have to launch a satellite. Now, before we start this topic, whatever we have discussed in the last 1 hour, if you have any doubts from there, please let me know. Anything that you want to ask? Black holes observed by radio telescopes? No, no. For black hole observation, we discussed yesterday that there are event horizon telescopes, which are a very different set of telescopes, but largely based on optical phenomena than radio. Please write in the PPT that what is dark sky reserve. Okay, let me write it. This is for observing the night sky. Hmm. Are radio waves harmful to us? I wouldn't say that. Otherwise, it would have been very difficult, because every bit of wireless communication, more or less, today is based on radio waves itself. But Aries was close to Pluto, so anyways, Pluto didn't have enough gravity to throw it off. It will be a dwarf planet only. So see, just understand this, that there was no concept of dwarf planet at all. They made this new phenomena, they added this new concept because of Aries. Otherwise, Pluto would have happily remained a planet. Is Oort cloud a ring or a spherical ball wrapping the solar system? You can say that it's more like a ring. All right, it's more like a ring, not spherical in that sense. Just one basic thing every one of you should remember, that the structure of this entire solar system is flat. I mean, not only the solar system, you can say the entire galaxy has a very flat structure, a kind of a two-dimensional structure. Everything is aligned in one line. So it's not that there is, let's say, they are three dimensional in one way or the other. And this is mainly because of, I mean, simple laws of conservation of angular momentum. I'm not going there because it's too much physics, but because of laws, because of the conservation of angular momentum, they would have this kind of a two-dimensional structure. So that's why these are all like rings and not spherical. I also read that Pluto hasn't completed its orbit since 1930. Is it true? It is true because Pluto takes a total of 248 years to complete one revolution. Oort cloud. Oort cloud, just remember that we are saying that this is the edge of any given star system. So, in this particular scenario, what we basically see is that there can be a lot of objects, a lot of icy objects which might be found in this area, which are now completely away from the gravitational influence of the sun. So, in a manner, they define the end of the solar system. Can we call planets and moon are all celestial bodies? Yes, you can say that. Radio waves travel longer than any other waves. Yes, they do. And let us discuss this in detail when we go to IT and communication chapter. They will discuss about all the electromagnetic waves. So you'll understand that better there. Explain terrestrial planets, please. So terrestrial planets basically is a word, a concept that we use for the four inner planets: Mercury, Venus, Earth, and Mars, because these have a solid surface. All the other four, Jupiter, Saturn, Uranus, and Neptune, they are called as gaseous planets because they are like balls of gases, balls of gaseous mass. But the planets which are in the inner part before the asteroid belt, Jupiter, sorry, Mercury, Venus, Earth, and Mars, they have a solid surface and they are called as terrestrial planets. Telescopes are made of lenses and mirrors and a combination of those to make things possible in this sense. Can't understand how comets get that tail shape only by coming near to the sun. So basically what happens is that as they come near the sun, this is where all the frozen gases and dust particles, they they just start to uh, get back. I mean, they start to just, because of the motion that is in one direction, motion is, let's say, in this direction, then in that case the tail will be formed in this direction. So overall what happens is that in this particular scenario, you have the sun here, it starts to melt, and because of the motion, because of the momentum, it starts to gets thrown off in the opposite direction. How many total number of telescopes? I mean, uncountable. There are many telescopes, and every country has a lot of telescopes. Where you stayed there at night? Oh, there was, I think, there was one homestay where I had stayed. Differences between meteoroid, and meteor. Simple, that meteor is a meteorite that has come to the earth and burns off completely while it reaches the earth. I don't know the meaning of electromagnetic waves. We'll discuss that in IT and communication. Don't worry. Third condition of the planet, what I'm saying is that if there is any other celestial body in the vicinity of a planet, then in that case it should either be revolving around the planet or should not exist at all. So if there is another celestial body which has an independent orbit around the sun near this planet, then in that case this is something that will not count as a planet. Did Earth at one point have two moons? I'm not sure. I've not read about it. Please, radio telescope again. I mean, radio telescope is nothing but the telescopes that would observe the outer space with the help of electromagnetic radio waves, basically using the radio waves for observation. Not really. If there is, if they are in the current affairs, then only, otherwise not. Can I say Mars is in the Goldilocks zone, which is similar in atmosphere as the Earth? So not only Mars, but even in case of Venus, also Venus lies in the Goldilocks zone. Does that mean asteroids were once a planet, once planets, or were never able to form planets? What is the role of the birth of Jupiter in case of formation of asteroids? So basically, it may so have happened that because of the presence of Jupiter and presence of, let's say, these planets on the both the sides, Mars and Jupiter, the asteroid may never have found, and we believe that this is one of the major reasons. First slide of the second section. This is the first slide. Would you talk about X-rays, infrared, and radio rays? I mean, in IT and communication chapter, we will. The difference between terrestrial and the jovial. It's not jovial. It's Jovian. It's not L. It is N. So Jovian planets basically are the gaseous planets that we just spoke of. Jupiter, Saturn, Uranus, and Neptune. They are called as Jovian planets, and because they are like Jupiter, Jovian comes from Jupiter. So Jupiter-like gaseous planets are called as Jovian. Bennu is the sample of asteroid collected from space, or this asteroid comes to Earth, then NASA. No, we have collected samples from the asteroid that is named as Bennu. The name of the asteroid itself is Bennu. Is heliopause the outer edge of the heliosphere, which acts as the surface of the bubble that surrounds the solar system? Is it the part of the Oort cloud? No. The term helio means something related to the sun. So wherever the sphere of influence of the sun ends, that is called as heliopause. Why don't we discover what's inside a black hole? It's not about don't, but it's about can't. It's very difficult to see inside a black hole, and hence we are not able to. Can you bring back the pic that you talked about yesterday? Oh, I did not. Fine, I'll bring it tomorrow. So tomorrow we may not have a class. I think it's in Republic Day. There are so many terms. We should focus only on those which are in the news. I mean, not only the ones which are in the news, but some of these things that we are discussing here. These are static important areas. So that's why they should remain important irrespective of the news. What kind of mains questions can come from this chapter? We'll keep discussing as and when something like that comes up. How reduced gravity of the sun leads to existence of Kuiper belt. Basically what happens is that because gravity is less, smaller objects can remain there. Otherwise these smaller objects, if they were near the sun, they would have been pulled by the sun. But now that they are far away, the gravitational effect of the sun is less on them, so that's why they can exist there. Is tomorrow a holiday? Yes, it is. You must have taken picture at night as well. I did, but I did not have a good camera. I mean, and I did not expect what I saw. So the pictures will not do justice to what I had seen. Moving meteoroids are asteroids? We cannot say that. We cannot say that because asteroids have a very different origin than meteoroids. So that's why we cannot really say that they are actually the same things. So overall, uh, they are very different in nature. What is shoemaker levy? No, the spelling is wrong. It is shoemaker levy. So shoemaker levy is a comet that had broken off, I think, almost 20 years back. I think it was there. But I listen that Pluto has changed its orbit. So Pluto has a bit of different orbit than most of the other planets. I mean, it also has 5 moons. Even after that, it is not being called as a planet. Comet which comes near the Earth for every 74 years, not 74, I think 76, it's Halley's Comet. So I think I've answered most of the questions. Many of these are repeated questions. Why Mars is green planet? It's not green, it's a red planet. It's red because of presence of iron and iron oxides. I'm checking Hanle Ladakh. It's incredibly beautiful. Oh yes, it is. I mean, especially go with your notes. I mean, this is for everyone. Go with your notes. Nobody is there to disturb you. No phones will work. Nothing will work. So you can go and write 100 answers, and you can revise everything and come back. Exoplanets are outside the solar system, then how Mars is in Goldilocks zone? I mean, Goldilocks zone is for any star. Sun is also a star, so that's why the temperatures where I mean, the region where the temperatures are moderate, you'll call it as Goldilocks zone, irrespective of whether you are inside our solar system or anywhere else outside. Is there any need to know about the comets found in the past? 16 times asked. I already answered your question. You don't have to ask 16 times. This is for every one of you. I see that many of you just ask the same question 5 times or 10 times. What happens is because of that, I may miss some of the other questions. I will come to everybody's question one by one. Just that it takes time because one by one I'm answering everyone's question. So you don't have to ask the same question 10 times. There are total of, as I can see in the chat, there are total of 125 questions, out of which almost 60-70 questions are repeated questions. See, you have again. Is there a need to know about the comets found in the past? 17th time asked. Why do you have to ask it 17 times? I've answered your question. You have to be a bit patient. You are preparing for UPSC civil services examination. Patience is a virtue that is always expected out of any aspirant. All right. So more or less, I've discussed all the questions. Let's move on uh, to the next topic, and this is about ground-based observations. Now, until now, sorry, space-based observations. Now, until now, what we have discussed is about telescopes. Now we come to the uh, discussion of the satellites and how do we launch a satellite, and also we'll discuss why do we launch a satellite. So, for launching a satellite, first and foremost, we need to ensure that the satellites remain in their orbits. Orbits meaning the regularly repeating path that they would have around any object, maybe around the Earth, maybe around Mars, maybe around the Sun, maybe around the Moon, whatever it is. So, for that, we need to ensure that when they reach their orbit, they keep on existing in their orbit, they keep on revolving in their orbit. So for doing that, what we need to do is we need to apply certain basic physics. Now, overall, when it comes to the basics of what helps in this particular scenario is that in case of objects staying in the orbit, Newton's first law becomes important. Anyone who remembers Newton's laws of motion? Do you remember what's the first law of motion? Yes, law of inertia. That's correct. So, what the law of inertia says is that an object at rest will remain at rest, an object in uniform motion will remain in uniform motion unless an external force applies on it, unless an external force acts on it. So, unless an external force is applied, the object will maintain its status quo. So whether it is at rest, it will remain at rest forever. If it is in uniform motion, it will remain in uniform motion forever. Only if a force is applied on it externally, then only uh, there will be a change in its state, right? So an object at rest will remain at rest unless an external force applies on it. Now, this is something that becomes very, very crucial for even our satellites. Any satellite that we are launching, anything that we are launching, for that, this becomes very, very important because we now are talking about balancing the forces. We are talking about balancing the forces. So, so just understand this that let's say you have an object, if you have an object kept on a surface which is at rest, all right, it is at rest. Now, what happens is that I start applying force in one direction. Suppose that the force that was required, by its virtue, it has a 10 Newton force. So I need to apply at least some extra force than 10 Newton so that it will start moving. So now what happens is that it starts moving in one direction. Now, in this particular scenario, when it comes to the balancing of the forces, unless there is an unbalanced force in one direction, the movement cannot happen. And as soon as you balance the forces from all the sides, it will remain in its place. So now this is where we need to ensure that if let's say we are launching a satellite, suppose that a satellite is supposed to be launched at 1000 kilometers above the earth. So now what we need to do is that the forces on this satellite at 1000 kilometers above the earth should be balanced, and only if it is balanced then only it will keep remaining in its orbit, right? So that is what basically is done, that we have to balance the forces, all right, we have to balance the forces. Now understand this, that I'm just writing here forces. Let's say if a satellite has to orbit the earth 1000 kilometers above the surface, then the forces acting on this satellite at this point should be balanced. All right. So this is basically what we need to do in terms of a satellite. So now here just understand this, that there is one natural force which is always acting on the satellite. What is that natural force? Can you think of it? There is one natural force which is always acting on this satellite that we are launching. What is that force? Gravitation. Perfect. So gravitation is acting on this satellite anyway. What we need to do is we need to counter that gravitation. If we want, let's say that the satellite has to be at an orbit of 1000 kilometers above the earth, then at 1000 kilometers you have to ensure that whatever is the force of gravitation, an equivalent force is being applied on the other side, right? So here there are two concepts which are called as centripetal force and centrifugal force. Centripetal force has to be equal to the centrifugal force. Centripetal force has to be equal to the centrifugal force. Now in this particular scenario, the centripetal force basically is the gravitational force. Centripetal force is the gravitational force and centrifugal force is the force due to motion. So this is why we launch a rocket. When we launch a rocket, you'll see that enough energy is provided to it, enough force is provided to it so that it can escape the gravitational force of the earth, and then it will be able to rise above. So the amount of thrust that will be given, the amount of force that will be applied on this satellite will depend on how far do you want that satellite to go. So depending on that, all the calculations will be done, and depending on that only we will try to get to the required location. So it's all about just balancing of the forces, balancing of the forces from all the time, all the sides. So there is one gravitational force, you have to apply an equivalent of the gravitational force in a manner that at 1000 kilometers it goes and becomes uh, uh, sustainable in that orbit. So the basic is this. The basic phenomena here is only this, that you have to try and balance the forces from both the sides. And if you are able to balance the forces, you will be able to launch the satellite into that orbit. Although practically things are not that simple, uh, rocket science is called as rocket science for a reason. Because there are a lot of variables that come in the picture. Because here, for example, we have assumed that Earth is round. Earth, you know that it's not a perfect sphere. Then even the orbit has been uh, assumed to be perfectly spherical. That's also not the case. In most of the cases it is elliptical. Then after that, satellite has a variable mass, because satellite has fuel, and as it is launched, as it goes above, it keeps on losing its fuel, so its mass is also variable. Then the effect of gravitation and at every point on the earth is also different, so the forces being applied are also different. Then there is the atmosphere, and atmosphere also apply a frictional force to this satellite, so that also has to be taken into account. So there are a lot of these things that have to be taken into account, and then only we are able to launch the satellite in practicality. So that's why practically it's not that easy to launch a satellite. But the basic is this, the basic idea behind launching the satellite is this, that we are trying to launch the satellite in a manner that we can balance these forces. Look at this question, kind of a difficult question, but this was asked in your paper. Just read the question and then I'll launch the poll for you. Let me launch the poll. Please mark your answers. The Earth revolving around the Sun in elliptical orbit. The orbit that we are talking now is also one and the same. Yes, all the orbits are the same, and the basic physics applies to all the natural orbits and all the man-made orbits. Just that in the natural orbits, it is naturally determined, and nature is playing its part in determining those orbits. And in the artificial orbits, we are the ones who are making those orbits, creating those orbits according to our requirements. Have you watched Interstellar? Yes, I have. Balance keeps the satellites in motion. That's correct. Balance will keep the satellite in motion. Uh, okay, so poll, I can see that 52% of you have marked D and 30% of you have marked C. So it was expected that there will be confusion between C and D. So let me just discuss this with you. The artificial satellite orbiting around the Earth does not fall down. This is so because attraction of the Earth. First is does not exist at such height. That's impossible. We discussed that there is this force, right? There is the force of gravitation, so that is what the attraction is. So that cannot be the case. Is neutralized by the attraction of the moon. That's also not possible because moon is very small. Moon is very small, and because of that, moon will never be able to balance it out because Earth is very big and has very strong gravitational force, much stronger than that of the moon. And also moon is 384,000 kilometers away. Most of the satellites that we are launching, it's just around 500 600 kilometers above the surface of the Earth, maximum of 36,000 kilometers above the surface of the Earth. So that's it. And moon is approximately at 384,000 kilometers away from the Earth. So that's why moon cannot neutralize the attraction of uh, the Earth. So that's why A and B are wrong. The main confusion starts between C and D. C says provides the necessary speed for its steady motion. D says provides the necessary acceleration for its motion. Now, what is the basic? We are saying that you have to balance the forces. Do you remember what the formula for force is? I'm sure many of you do. What is the formula for force? Yes, F equal to ma. Force is equal to mass into acceleration. Now, in this particular scenario, mass actually does not count. Mass, because mass is constant, so mass does not determine the orbit. It does not determine the orbit as such. Acceleration does. The the acceleration that you actually give will determine the kind of force that you are providing, because mass is constant. So for example, let's say you have a satellite. So the mass of the satellite, let's say if it is 500 kg, it is 500 kg. Now where you want to send the satellite, depending on that, the initial acceleration will be provided, the initial force will be provided. So that's why D is the correct answer. And also understand why not speed, because speed only talks about the magnitude. It's not only about the magnitude but also where you are sending it. So there is an acceleration that you are providing. So acceleration being provided also means that there is a change in speed and maybe also a factor of direction. So speed does not take direction. You might know that there is a difference between these two concepts of speed and velocity. right? Where speed has only magnitude and velocity has magnitude and direction. So we say that it is, that's why it is called as a scalar quantity, and this is also called as a vector quantity. So that you may not need to know this, but overall what happens is that in this particular scenario, it's not only about the speed, or not only about how much speed you are providing, but also in what direction you are providing. So that's why speed and direction both have to be taken into account. So that's why it needs to provide the necessary velocity that is required for this to happen. So that's why, let's say if c, uh, because it is saying speed, it is wrong. But let's say if this option would have said necessary velocity for its motion, so for example also, that it is not a steady motion, it is a variable motion. So if let's say c said provides the necessary velocity for its motion, then in that case it's impossible to choose between c and d, and I would just leave this question and go on to the next one. But because it says speed and it says steady motion, that's why I would say that c is also not correct and d is the correct answer. So it's a difficult question. I wouldn't say that it's an easy question by any stretch of imagination, but they have asked it what to do. Now, next, coming to the different types of orbits. Now when it comes to the different types of orbits, let me take this after a break. I mean, because this is a new topic and it will continue for a while. So that's why I'll take it. Yeah, there is no need to know about what is scalar and what is vector quantity. I just gave you as an example. Why take F equal to ma and not mg? G is anyway acceleration, so it's not, G becomes specific. I'm saying force. When I say force due to gravitation, then F is equal to mg. But when I say just force, then force is equal to mass into acceleration. All right, so it is 7:40. Let's come back by 7:55 and let's continue with our discussion. Welcome back, everyone. So now we start with the basic different types of orbits. So we'll see what are the different types of orbits, what are the factors that determine an orbit, and all these orbits, how are they associated with a satellite, how are they associated with some kind of application or the other. So we'll discuss about all these aspects. Now, you might have heard about a lot of different types of orbits, that there are geosynchronous orbits, geostationary orbits, sun synchronous orbits, polar orbits, equatorial orbits, and whatnot. But all these orbits basically can be categorized into three parts: low Earth orbit, medium Earth orbit, and high Earth orbit. So, first, we'll try to understand what do we mean by these three. What's low Earth orbit, what's medium Earth orbit, and what's high Earth orbit. Now, overall, when it comes to these orbits, low Earth orbit is any orbit that lies in the range of 180 to 2000 kilometers. Medium Earth orbit is all the orbits between 2000 kilometers to up to 35,786 kilometers. And geosynchronous and high Earth orbits are at and above 35,786 kilometers. Now, we are starting with 180 kilometers because this is where you can say the atmosphere of the Earth ends. This is the end of Earth's atmosphere. This is the end of Earth's atmosphere, and so starts from there and up to 2000 kilometers, they are called as low Earth orbits. Starting from 2000 kilometers going up to 35,786 kilometers is called as medium Earth orbit, and everything at or above this number of 35,786 is called as high Earth orbit. Now, also, so one end we understand 180 kilometers and why 180 kilometers. On the other hand, why this specific number? 35,786 kilometers. Why such a specific number? Also, try to understand this, because when you are at this height, when you are at this height, this is where the time period of revolution is of 24 hours. So, what is the significance of 24 hours? It is also the rotational period of the Earth, correct? So, what happens is that any satellite which is at 35,786 kilometers, it will revolve as the Earth rotates. So, as the Earth is rotating, it also keeps on revolving. So, then what happens is that it is always stationary with respect to a certain point on the Earth. It will look like a fixed star above that particular place. So that is why the revolution period of 24 hours has a significance. And calculating this, the distance at which we have to keep the satellite is 35,786 kilometers. So that is what the importance of this particular number is. And we'll discuss more in detail when we go to the discussion of high Earth orbits. Now, there are three factors that would determine the orbit. All right, that would determine what an orbit is. So, these three factors: first factor is height. Now, when it comes to height, just understand the value of this particular orbit. Now, suppose that this is the Earth. All right, let's say this is the Earth, and I define here 2 points. Let's say this is one point A, and this is another point B. Now I have a question for you. If I had to take pictures and videos of the Earth, if I had to take pictures and videos of the Earth, would I prefer A or would I prefer B? Launching a short poll for you. Please mark your answers quickly. So if I had to take pictures and videos of the Earth, should I Pick A or should I pick B? It would be rotation. No, no, no. It's not rotation because we are talking about revolution of the satellite, rotation of the Earth, but revolution of the satellite. So at 35,786 kilometers, the revolution period, the orbit period of the satellite is of 24 hours. So it's not rotation in that sense. I think you got confused there. Hmm. So 38% of you feel that it should be A and 62% of you feel that it should be B. Can you give me reasons? Why do you think A or why do you think B? You'll have to tell me with A or B because I don't know what you have answered there. Range of view, cover more area, better resolution. Yeah. Uh, Animesh, you are correct. Shreyank, you are correct. Hemlata, you are correct. Satyam, you are correct. Dinesh, you are correct. Hmm. So now for all of you who have picked B, the logic that you are giving, the logic is that you would have better coverage, right? You'll be able to cover more area on the earth. But think of this: if I give you a camera, let's say you have a phone camera and you want to take pictures, all right? I ask you to take pictures from your phone camera. So would you take, I mean, would you be far away from the subject or would you go near the subject to take that picture? If you have to take better pictures and better videos, you would want to be near the subject rather than being far away from that, because when we are taking pictures, range normally is not our concern, right? How much we are covering normally is not our concern. Better quality is the major thing that we are looking for. We want better clarity, better pictures, and that's why for that we try to remain as close as possible. So that's why in this particular scenario also, this actually holds good, that when we have to take pictures and videos of the earth, a better suited point would be A. All right, better suited point would be A. Then I have another question. If I had to launch a communication satellite, if I wanted to launch a communication satellite through which mobile phone communication has to function, should I pick A or should I pick B? Should I pick A or should I pick B when it comes to communication satellite? Yeah. So 57% of you have marked B and 43% A. Can you again give me a reason? Those of you who feel A or those of you who feel B, why do you feel A or B? Yeah, Dinesh, you are correct. Rajneesh, you are correct. Kennedy, you are correct. Pooja, you are correct. Shreyank, you are correct. Nikhat, you are correct. Sakshi, you are correct. So many of you have given the perfectly correct answer, because in case of communication, range is very, very important. If let's say a particular satellite is covering lesser area, then in that case its communication will be very localized. You would want a better coverage, and at the same time just also understand that our preference would be B. But it's not that you cannot launch a communication satellite to A. That is, it's not that you can't be near the earth for a communication satellite, but the problem would be your cost will be very high. Your cost of operation would be very high, because what happens is that A will have a lesser range compared to this. B will have a better range, right? So what happens is that if you are keeping a satellite at A, you will have to keep multiple such satellites. You'll have to keep multiple such satellites to do the same job instead of having just one satellite. So that's why if you will not be cost effective in your operations if you are keeping the communication satellite at A. So that's why pictures and videos we would prefer A, and communication we would prefer B. So that's why what we observe is you will see that all the remote sensing satellites or the earth observation satellites, they are kept in the low earth orbit because they have to take pictures and videos of the earth. So they are kept in the low earth orbit. And our communication satellites, which are for whether mobile phone communication, telecommunication, television, radio, whatever it is, for all that, the communication satellites which are kept, they are kept at B, that is high earth orbit. Largely we'll focus more on high earth orbit. So that's why in that scenario, we see that B would be preferred for communication purposes, A would be preferred for observation purposes. All right. So that's why Earth observation satellites will be launched at low Earth orbit and communication satellites largely in the high Earth orbit. So that's why height as a factor becomes very crucial. Then the second factor is eccentricity. Now, eccentricity is something that determines shape of the orbit. It determines the shape of the orbit. So eccentricity is a value that we see in any ellipse or any elliptical figure. And what we see in these kind of scenario is that as the value of eccentricity lies actually between 0 and 1, it is always less than 1 for an ellipse. So when the value of E is equal to 0, when E is equal to 0, this is where it becomes a perfect circle. And when E is equal to, let's say, 0.9999 so on, then in that case it is highly elliptical. It is highly elliptical. So in this manner we see that this is how it determines the shape. And shape is also important, and we'll take an example later where you'll understand how shape also becomes an important factor. Then the third one is inclination. Now, inclination from the equator, whether it is an equatorial orbit or a polar orbit, will be determined on the basis of inclination. So, equatorial and polar orbits will be determined on the basis of this. All right. So, this is how we are talking about these three factors, and these three factors become very crucial in determining what kind of orbit we are setting up depending on what is our requirement, what is our application. So based on that we look at all these three factors. Now when it comes to these orbits, one by one we'll go through all these orbits and also try to understand what these orbits are and how these orbits become useful for us in one way or the other. First to start with is low earth orbit. Now, in case of low Earth orbit, there are two types of orbits, one called as the polar orbit, second one called as the sun synchronous orbit. Now, sun synchronous orbit also is not very different from a polar orbit. In a manner, we can say that it's a special case. It's a special case of polar orbits. Special case of polar orbits. These are called as sun synchronous orbits. Now, in this particular scenario, when it comes to the sun synchronous orbits or the polar orbits, they are both low Earth orbits and they would be useful for Earth observations. So, just a few points which are important for low Earth orbits. First, their height. Height is between 180 kilometers to up to 2000 kilometers above the surface of the Earth. Then, their application. Application is Earth observation. Earth observation. Then orbit period, or the period of revolution, is 1.5 to 2 hours of time. So they would complete one orbit around the Earth in just 1.5 hours to maximum of 2 hours. So orbit period is 1.5 to 2 hours of time. Then after this, one more point that is very, very important is that the launcher that is used to launch them is PSLV, and we'll discuss more about PSLV when we discuss about launch vehicles at a later stage. So the launcher that is used is PSLVs, and these are lightweight satellites. These are lightweight satellites. Normally, you would see that they are in the range of 500 to 700 kg. Now, this is not fixed, but normally in the range of 500 to 700 kg, and their total life cycle, their total life cycle is normally between maximum of 5 years, between 3 to 5 years. All right. So we see that these are some of the basic features of any low earth orbit. All right, these are the features of any low earth orbit. Now in this we are saying that there are two types of orbits. One is polar orbit and one is sun synchronous orbit. Now in case of sun synchronous orbit, we are saying that it's a special case of polar orbits. Now why we are saying this is, understand the term sun synchronous. It is called as sun synchronous because it is synchronized with the movement of the sun. So what we say is that in case of sun synchronous orbits, it is synchronized with the local solar time of a place. Now understand the meaning of this phrase, synchronized with the local solar time of a place. So what we observe in these cases is that when it comes to uh, the sun synchronous orbit, any satellite which is in the sun synchronous orbit will pass over a certain point once in a day. That, let's say for example, if you are living in Delhi, so over Delhi it will pass over Delhi once in a day. So every day it will come over Delhi at the same exact time. That, let's say if it was here at 10 a.m. today, then tomorrow again it will come back at 10 a.m. Again the next day it will come back at 10 a.m. and so on. Now, you might think that on one hand, I'm saying that the orbit period is just 1.5 to 2 hours, meaning that one revolution is being completed in just 1.5 hours. Then, how is it the fact that it is taking one whole day for it to return back to the same point? Can you think why this is happening? That although the revolution period is of just 1.5 hours, but it is coming back to the same point only 24 hours later? What is potentially the reason? Yes, Megha, you are absolutely right. I'm waiting for more correct answers. Yes, Rajneesh, you are correct. Vishmanjali, you are correct. Sahil, you are correct. Animesh, you are correct. Hmm. So, yeah, Lekni, you are correct. Ramit, you are correct. So, fine. So, many of you have given the correct answer. This is because of the rotation of the earth, because earth does not remain static. While it is revolving, the earth is also rotating. What has been shown here in these pictures, that by the time it comes back on the same latitude, the earth has moved because of the rotation of the earth. The earth has moved, so it does not come back in the same point. It left from here, it now came here. Next time it will come here, and then it will come here, and so on. So what happens is that in a manner, the rotation that is happening, it will ensure that it comes over the same point the next day, at the same at the given time. So what happens then is that you have a consistency in data. Suppose that it came over Delhi at 10 a.m., then at 2 p.m., then at 7 p.m., then at 10 p.m., then maybe at 12 p.m. at night, 12 p.m. At night. So then in that case, you will not have consistency in the data that you are collecting. But if you are collecting the data every day at 10 a.m. in the morning, then there will be a consistency on all the data that you have collected. So that's why we see that it would be synchronized in a manner that it is synchronized with the local solar type of a place. So that's why it is called as sun synchronous orbit. Now always remember that most of the satellites that we are launching, most of these satellites will be launched to the sun synchronous orbit. You will see this in the newspapers also. Whenever a new satellite is launched, you will see that the new satellite, they would say that the satellite has been launched to sun synchronous orbit, or they also use the term SSPO, because of sun synchronous polar orbit. Because as I told you, it's a special case of polar orbit because it is also in the polar regions only, just that with one extra feature added to it. So that's why these are some of the things related to the low earth orbit. Now all these things that we are discussing, basically they are related to earth observation or remote sensing. These are the two terms which are used for these applications: earth observation or remote sensing. And these are the various applications for which we can make the use of the low earth orbit or the satellites in the low earth orbit. So whether agriculture or study of bioreserves and the environment, cartography, geological and mineral resources, urban and rural development, disaster management, climate change studies, for all these things we can make the use of earth observation satellites. And this is a list that I've directly taken from ISRO's website. ISRO has listed out all these applications for earth observation satellites. All right, now in this particular scenario, when it comes to earth observation satellites, there are many satellites that we have launched over the past 2 decades, where you have examples like cartosat, oceansat, resourcesat. A basic nomenclature is this, that the application plus the word sat, this kind of a nomenclature is used for most of our earth observation satellites. So what to remember: earth observation satellites will be launched in the low earth orbit. They are lightweight satellites, they are functional, they largely would complete one revolution or one orbit in 1.5 to 2 hours. And then these will normally be launched with the help of PSLVs. So we'll discuss about all these things anyway, that what PSLVs are. Because what's also needed is that you should understand that all these parameters are related to one another. Many a times when a question comes in the examination, even if it is a current affairs based question, on the basis of these basics you will be able to answer the current affairs question also, without sometimes without even knowing the current affairs. All right, without even knowing the current affairs, sometimes it is possible to answer these kind of questions. Let me give you an example. uh, 2015 we had launched astrosat. All right, astrosat is, you can say, an x-ray, largely an x-ray observatory for India. So 2015 astrosat was launched, so obviously next year a question was asked on astrosat. Now this question that they had asked on astrosat, one of the statements, so astrosat was launched with the help of a PSLV. Now one of the statements which was launched, which was given in the question paper, was that astrosat is a 2000 kg satellite. Now because PSLV is being used, PSLV is not capable of launching heavy satellites. PSLVs only launch lightweight satellite, maximum up to 1500 kg, maximum 1500 kg. And the statement said that astrosat is a 2000 kg satellite. Now, on the onset, somebody might say that this is a very factual statement, and UPSC should not have asked such a factual statement. But the thing is that you do not even need to know whether it is 2000 kg or not for answering this question, because of just the fact that PSLVs were used. And if a PSLV has been used, it cannot be 2000 kg because PSLV does not have that capacity. So it's a wrong statement. So even without knowing whether or not it was a 2000 kg satellite, you can still answer that question based on these set of rules, based on these set of data. So that's why these kind of things can become important for you, because they will help you in answering questions even sometimes without knowing the information related to those things or those news. Then we have medium Earth orbit. Now, in case of medium Earth orbit, we understand that it is between 2000 kilometers and going up to 35,786 kilometers. Now, in this particular scenario, when it comes to medium Earth orbit, there are two types of orbits here. One called as semi-synchronous orbits, and the other one called as Molniya orbit. Now, semi-synchronous orbit, understand this, semi-synchronous completes one revolution in 12 hours. So it has a 12 hours orbit period, meaning it completes revolution around the earth twice in a day. It has been placed at 20,200 kilometers above the surface of the earth. 20,200 kilometers above the earth, and it is something which is used by GPS. GPS, the navigation satellite you might know of. So GPS uses semi-synchronous orbit. Now, in case of the other orbit, that is the Molniya orbit. Molniya orbit is a very interesting orbit. First and foremost, when it comes to the origin of Molniya orbit is something that was invented or designed by Russia. And this is where they place communication satellites. Now, there is one problem that Russia has been facing, or Russia was facing, because of which they had to design this orbit. Normally, what happens is that a communication satellite is normally kept in the equatorial orbit, like this. And even if it has a good range, let's say if even if it has a good range, what happens is that it is not really able to cover the poles, the north pole and the south polar regions. They cannot cover it well. Now, in the south pole you have Antarctica, and you do not really have near the south pole you do not have presence of so many of those countries which need that communication support. But a large part of Russia is in the Arctic zone in the north, and hence it misses the services of the communication satellites from the equatorial orbit. So that's why they basically designed this orbit. They invented this orbit called as the Molniya orbit, where this, as you can see, that this is an orbit which is a highly eccentric orbit, and something that will cater to Russia better. So what happens in this particular scenario is it is highly eccentric. Remember, we discussed about shape being a factor, also one of the major factors in determining an orbit. This is where the aspect of shape being a major factor comes into the picture. That this is where they are using this particular shape. Now, why they are using this shape also has a reason, that when a satellite is near the Earth, they always travel faster, and when it is away from the Earth, they will travel slower. So that's why when it is in the northern hemisphere, it will travel slower, and it will spend a lot of time in the northern hemisphere. And as it comes to the southern hemisphere, it will become very fast, and it will quickly cross the southern hemisphere. So that's why it will be usable for Russia. It will be usable for Russia, and that's why Russia designed this particular orbit, so that they can use this orbit for their communication requirements. Now, this is the official information, right? This is the official information. And then there is another side of the story. and that side of the story comes from the US. Now, this was when this design happened, this was the time of the USSR and Russia and the Cold War era. So that's why anything said by USSR, US would never believe it. Anything said by the US, USSR will never believe it. So when Russia, or back then USSR, said that this is a new orbit that we have invented, because we were facing these problems with our communication satellites, so we thought that this is the requirement, and hence we have invented this new orbit, and all our communication satellites will start going into this orbit. US said that, see, USSR is lying, Russia is lying, because this is a satellite, this is an orbit that they are going to use to keep their spy satellites. This is where they are going to spy on us from, because this is a new orbit, nobody knows, nobody can track this orbit, so it becomes easy for Russia to send spy satellites to this particular orbit. So that was the US side of the story. That Molniya orbit was not meant for any communication requirements, but it was meant for spy satellites to spy over the US. So that's their version of the story, but we can't say whether that's a version that is correct or not, because the official information presented by Russia was this, that because normal communication satellites are not usable for the higher latitudes of Russia, hence they had to invent this orbit and keep their communication satellites in this particular orbit. So this is what the medium orbit is. Now, in case of medium orbit, what we see is that largely medium orbits are used uh, uh, for navigation purposes. Now, whether it is GPS, whether it is the other systems, let's say, even if you think of the other systems like, let's say, you have Galileo system, or maybe you have the quasi zenith system of Japan. So there are all these systems that we have, and most of these systems you'll find that they are in the low, in the medium Earth orbit, and there are not a lot of aren't a lot of let's say such navigation systems in the world. There is one GPS, then there is Navik of India, then there is Galileo, belongs to Europe, and then after that, GLONASS of Russia, BeiDou of China, and Quasi Zenith of Japan. So these are some of the navigation systems that are available across the world. Now, when it comes to these navigation systems, what we see is that in these navigation systems, there are two navigation systems that India has been using. One called as the Gagan system, and the second one called as the Navik system. Now, in case of India's navigation, the story is not very similar, because we do not use a lot of medium Earth orbits, but instead we use high Earth orbit for navigation. For example, in case of Navik, this is basically based on high Earth orbit, whereas Gagan is a mix of medium Earth orbit and high Earth orbit. So that's why our navigation systems are a bit different in these kind of scenarios. Now, when we look at these systems, one is the Gagan system and the other one is the IRNS system. So the Gagan system is something that has been uh, designed in India. The Gagan architecture has been designed to help civil aviation needs, to help in civil aviation. So primary objective is civil aviation. Apart from that, obviously there are some of the other uses also. It can be used in waterways, in roadways management, in railway management, in geological studies. In all these cases, Gagan satellite system can be used, but primarily it has been designed to look after the civil aviation of the country. Now, to help in civil aviation of the country. Now, understand how exactly that can happen and how it can help in these kind of scenarios. Now, so that's why Gagan, when you look at Gagan, Gagan means GPS aided geo augmented navigation. That's why GAGAN, Gagan system. Now, in this particular system, what we are saying is that this has been jointly implemented by ISRO and Airports Authority of India. And this is going to help in civil aviation applications in India. civil aviation applications in India. Now, in this particular scenario, when we look at the Gagan system, apart from that, it does help in other systems, other areas as well. So whether transportation, maritime, highways, railways, all these areas is where Gagan system becomes useful. So as you can see in this picture, it is a combination of two sets of satellites. You have the GPS satellites that it utilizes, which is in the medium earth orbit, and then you have the geostationary satellites which are in the high earth orbit. So that's why it's a mix of medium and high earth orbits, and we get this help in civil aviation. Now, in what sense does it help? How does it help in civil aviation? What we see in case of Gagan is that the Gagan system will help in reducing the travel time. Reducing the travel time. So now reducing the travel time also means that you are able to reduce the fuel consumption, right? You're also helping in reducing the fuel consumption. So fuel consumption being less also means reducing the cost, right? It also means reducing the cost, and more importantly, it also makes the entire operation eco-friendly. It makes it environmentally friendly. So that's why we see that there are all these things it will help with when it comes to civil aviation. It will try to shorten the path. It will try to shorten the path of travel, and that is why we are saying that it will help in reducing the travel time. So overall what it does is that shortens it will help in shortening the flight path. It will help in shortening the flight path, and that is the reason why it will have an effect in all these cases. So this is what the Gagan system is, a mix of medium earth orbit and high earth orbit. Let me use another color. I think white suits better. Hmm. So this basically is where you have the medium earth orbit, and this is where you have the high earth orbit. Next, we have the IRNSS system, that is Indian Regional Navigation Satellite System, where we have a set of seven satellites, three geostationary and four geosynchronous satellites. Now, overall, so this is how the arrangement is. You have three geostationary satellites, one, two, and three, and there are four geosynchronous satellites. Right, so there are four geostationary satellites and three geostationary satellites. So these seven satellites together, they are forming the Indian Regional Navigation Satellite System, which is also called as NAVIC. NAVIC meaning navigation through Indian constellation of satellites. So that's why the term NAVIC is being used here. Now, in this particular scenario, IRNSS becomes, you can say, the replacement of GPS in India. Replacement of GPS in India. So overall, what we see is that this is a navigation system to provide positioning, navigation, and timing services for users over the Indian as well as the region extending up to 1500 kilometers beyond its boundaries. So a set of or a constellation of seven spacecraft, seven satellites, where you have three, as we discussed, that there are three geostationary plus four geosynchronous satellites. Now, in this particular scenario, the IRNS system, as I told you, that it can become replacement for GPS. It can become replacement for GPS. And there are two types of services that it provides. One called as the standard positioning service, and the other one called as the restricted service, which is also called as precision positioning service. Precision positioning service. All right. So now, when it comes to standard positioning service, this is basically a service that will be provided to all the users. Whereas when it comes to restricted service, it will be provided only to the authorized users. Now, what we are able to do here with the help of this IRNS system is that all the areas, let's say, which are sensitive, all the areas which are strategically important. So, in these kind of areas, we ensure that the access only lies with the people who are allowed to have the access to those areas. So for example, the areas where our satellites are kept, areas where our missiles are kept, anything related to defense, anything, a zone which is sensitive. So there are all these things that can be done, and we can put restrictions on that. So that is something which becomes important from internal security matters. So that's why it becomes important to have this division between these two systems. Now, overall, when it comes to the IRNSS system, we are saying that it's a replacement of GPS. For example, if you're using maps, like for example, Google Maps, if you're using, then largely uh, Google Maps have been using GPS. But over the last couple of years, we have seen that now IRNSS systems have started coming into the Indian markets, and the services of IRNSS are now available. And many of, for example, the phone companies, instead of coming with a GPS chipset, they have started coming with an IRNSS chipset. So for example, Xiaomi in India became the first such company to start doing that, and then after that we have seen that a lot of other companies also have followed the suit. Only the two of the biggest companies, Apple and Samsung, had not done it until the last year, and they also have been advised by the government of India that they also should shift. They also should switch to IRNSS in India, because in case of GPS system, GPS belongs to the US. GPS belongs to the US Air Force. So that's why it's a system being managed by some other country, which is not good for India's security. And IRNSS system or Navig system is completely indigenous, completely Indian. So that's why we know that it will not be misused by some other country. So that's why, in case of GPS, we see that there are all these kind of issues that we have with GPS. And uh, the work on IRNSS, it began almost, I could say, back in 2001. And this was, you can say, an effect of what happened in the years, couple of years before that. In 1998, if you know, and if you have seen this in history, then in 1998, India had done a nuclear test at Pokhran. India had done a nuclear test, and while India was doing this nuclear test, it was completely a secret. Nobody knew that India is about to do a nuclear test, and there were some, I mean, some hints to the US, and some information with the US, and US, that's why, was also spying on India with the help of the same satellites. With the help of these satellites, in US started spying on us, just to see whether or not India is actually working on a nuclear program or on a nuclear test. So we had to ensure to keep it a secret, because if people knew that we are about to do a nuclear bomb test, nobody would allow us to do it. all the kinds of pressures internationally would have been put on India to ensure that India does not go forward with the test. So that's why we had to keep it a secret, but GPS satellites were tracking it. Then after that, in 1999, we had the Kargil War. And during Kargil War, you might know that in Pakistan had occupied some of the areas near Kargil and Dras sectors. So they had come out, I mean, they had come forward from the Pakistan occupied Kashmir into this the sites which completely are under India's control. So what happened is that at that point of time, India asked for US help. India asked for satellite images, GPS satellite images. US refused. US did not provide us with this information. So they used it for their convenience when they wanted to use it, and they did not provide it to us, even though they knew that India is on the correct side and Pakistan is not. Yet they did not help in that particular scenario. And these two incidents, in a manner, you can say that it also made India realize that we need to have an indigenous uh, s- source of having navigation. And this is where we see that uh, we started working on the project. 2001, this project got a go ahead from the side of the government of India, and then 2003 we started working on this IRNSS project. In 2013 we completed the project and we started launching these satellites. So that's why IRNSS has been very very important from security perspective of India as well, and that's why we need to understand all these aspects pretty well. Then after this, we have the global positioning system called as the GPS. Now, GPS is a constellation of 32 satellites. Now, in case of IRNSS, we discussed that it's a constellation of just 7 satellites because it is only about the Indian region, only covering India and up to 1500 kilometers beyond Indian borders, basically to cover the Indian Ocean region. So it's covering only this much of area. Whereas when it comes to GPS, GPS is covering the entire world. It's a global positioning system. So that's why a 32 satellite system. All right. So that's why it's so many satellites, and India has only 7 satellites because India is only bothered about the Indian subcontinent. So as we discussed that it is placed approximately at 20,200 kilometers above the surface of the earth. Now, overall, when it comes to GPS or any other navigation system for that matter, there is one concept that becomes very important, which is called as triangulation. Now, triangulation is a concept where we are saying that instead of using just one satellite, we use a set of three satellites together. We use a set of three satellites together so that we can ensure a better precision, because there are three different satellites placed at three different points and all taking the location of one single area. So that's why when you combine the data from these three satellites, you will get a more precise data altogether. So that's why the coverage area, let's say, of one satellite is like this, another satellite is like this, and the third satellite is like this. Then in that case, it will be able to provide the location of this area with a lot of better accuracy as compared to otherwise. So this is called as triangulation. So triangulation is set of three satellites providing location of an area. So that's why triangulation, from triangle. That's why three satellites. Although there is a fourth satellite also. In case of GPS, there is a fourth satellite also to add that extra precision to the data. So, and that's why overall it has an accuracy of up to 5 meters. It has a total accuracy of up to 5 meters, meaning that if it has pointed out an area, then that area is in just 5 meters radius of this. So that's why they have very high accuracy. In case of IRNSS, the accuracy is 20 meters, which we are bringing it down to 10 meters. but even 20 meters is a very good accuracy to have, and in the future we definitely will be able to reduce that number and will have a even better accuracy compared to where we are right now. Read this question, a very simple question. I'm launching the poll for you. Please mark your answer. It's a simple question. Hmm. So 51% of you have marked the correct answer. The question says, with reference to the Indian Regional Navigation Satellite System, consider the following statements. First, it has 3 satellites in geostationary and 4 satellites in geosynchronous orbits. We just discussed about this, that this is correct, that there are 3 in geostationary and 4 in geosynchronous. So first, absolutely correct. Second is IRNSS will cover entire India and about 5,500 square kilometers beyond its borders. We discussed that it would cover up to 1,500 kilometers beyond the Indian borders. So that's why this is wrong. Third statement is India will have its own satellite navigation system with full global coverage by the middle of 2019. Now, I don't know why you would think that this is correct at all. First, 2019 is gone. Second, here it talks about full global coverage. It's an Indian regional navigation satellite system. Indian regional navigation satellite system. It is only bothered about India and the Indian subcontinent. It's not for full global coverage. This is what we discussed, that GPS is meant for what? For the entire globe, for the entire earth. Whereas this is IRNSS, Indian Regional Navigation Satellite System, only meant for India and the Indian borders. So there is no point of even thinking of full global coverage, and that too by middle of 2019. 2019 middle is already gone. Correct answer will be only one. Now coming to high Earth orbit. Now when it comes to the high Earth orbits, there are 2 types of orbits. We have just discussed about this: geosynchronous orbits and geostationary orbits. These are depicted by GSO and these as GEO. Geostationary orbit and geosynchronous orbit and geostationary orbit. And even here, geostationary orbit is said to be a special case, a special case of geosynchronous orbits. Special case of geosynchronous orbits. Now, in this particular scenario, when it comes to an high Earth orbit, again, just to look at some of the basic data, height now is at 35,786 kilometers. Application application is for communication. Various different types of communication, whether it is television, internet, mobile phone, radio, whatever it is. So for communication purposes, it is used. Then orbit period, if you remember, in case of low Earth orbit was just 1.5 to 2 hours, whereas in this particular scenario it will be 24 hours, meaning it completes one orbit in 24 hours. Then the launcher that we are using here are GSLVs. They are heavy satellites, and that's why PSLVs are not used. If you remember, we discussed that PSLVs will be used only for lightweight satellites. So these are satellites which can be in the range of 2000 to up to even 6000 kg. So that's why their total mass is, they are bulky. So that's why PSLVs can't be used to launch them. And one more thing, their life cycle can be 15 to up to even 20 years. Life cycle can be 15 to 20 years. So that's why in this particular scenario they will last longer. Now from this perspective also, if you think of how communication becomes cost effective when you are at high earth orbit, that as I told you in that picture that we had seen between A and B, that it's not that you cannot keep your satellite at A, you can keep it in the low earth orbit if you want. But then what happens is that first of all you have to use multiple satellites, and that too those satellites will not be functional for very long. They will be functional for like 3 to 5 years maximum, and then you'll have to repeat them. Whereas in case of let's say a communication satellite, the life cycle is of 15 to 20 years, and hence it will last longer, so it becomes much more cost effective from that sense. So that's why these are some of the features of the high earth orbit. Now, in case of geosynchronous and geostationary orbits, also understand what is the basic difference between the two. What do we mean by geostationary orbit, and what do we mean by a geosynchronous orbit? Now, when we look at the differences just consider on the basis of all the factors that we had talked about. The first factor that we had discussed was height. So height in both the cases is equal, 35,786 kilometers. So height for both are the same. Then the second one, if you remember, we discussed about eccentricity or the shape of the orbit. Now in this case, when it comes to geosynchronous orbit, these are elliptical orbits. Whereas in case of geostationary orbits, these are circular orbits. So that's why an important you can say difference between the two, or specialization, because circle is a special ellipse, it's not a different shape, it's a special case of ellipse. So that's why we are saying that it's a special case. And then the third factor that we had discussed was inclination. Now in case of geosynchronous orbit, small inclination is possible. All right, small inclination from the equator. But in case of geostationary orbit, they have 0 degree inclination. 0 degree inclination or no inclination. So they basically lie on the plane of the equator. And because of this, what we see is that when you look at geosynchronous orbit, first of all, it is elliptical. So elliptical can have a variable shape. So there can be multiple shapes of this variable, and small inclination is possible. So you can have multiple orbits. So hence, in this particular scenario, multiple orbits are possible. Multiple orbits are possible. Whereas when it comes to the geostationary orbit, height is fixed. It is circular, meaning that height in a manner becomes the radius of this circle. right? Height becomes the radius of this circle. So shape is fixed, height is fixed, and even inclination is fixed. It has a 0 degree inclination. So that's why it is a unique orbit. This is a unique orbit. There is only one such orbit. There is no other orbit apart from just one orbit. Whereas when it comes to uh, geosynchronous orbit, there are multiple such orbits that are possible. So that's why it is something like this, that this is basically the plane of the equator, right? This is the plane of the equator. So the geostationary orbit lies on the plane of the equator, whereas geosynchronous orbit has a bit of inclination. Now, when it comes to the use, we know that it can be used for satellite communication. So telecommunication, telemedicine, teleeducation, television, mobile communication, radio communication, internet. In all these cases, satellite communication, we see that these orbits become useful. Now, the satellite systems that we have used here, there are two satellite systems. We have INSAT and GSAT. Now, INSAT basically and GSAT both mean the same thing. They have the same functions. They are the same type of satellite. Just that initially we did not have the capacity to launch our own satellites. So when in that scenario, when we did not have the capacity to launch our own satellites, this is when we used to call it as an INSAT satellite. And then we built our own capacity when the GSLVs came into existence. This is where we see that we started calling these satellites as GSAT satellites. So it's more about how these nomenclatures are around the different types of launchers rather than functionality. Look at this question. This was also asked in your paper. I'm launching the poll for you. It's an easy question. Hmm. So 57% of you have marked A, which is the correct answer. It's an easy question. It should have been more than this. See, the question says satellites used for telecommunication relay are kept in geostationary orbits. A satellite is said to be in such an orbit when orbit is geosynchronous. We discussed that it is a special case of geosynchronous. This is what we discussed. So yes, this is correct. The orbit is circular. We discussed this, that it is circular. The orbit lies in the plane of the equator. This is also correct. We discussed that it has a 0 degree inclination. The orbit is at an altitude of 22,236. Is that so? What is the number that we discussed? 35,786 kilometers. I have uttered these numbers so many times that even in your sleep, when you are dreaming, you will still hear the numbers 35,786. So that's why it was an easy question because of this one statement. Because you have 4 here, you have 4 here, you have 4 here. So the only correct answer that we are left with anyway is 1, 2, and 3. That even if you are confused with 1, 2, and 3, only option number 4 or other statement number 4 gives you the correct answer. Now, coming to some of the other satellites. Now, when we look at all these satellites, we discussed that there are many applications, whether it is mineral monitoring, soil monitoring, agriculture, disaster management, climate change studies, weather monitoring, communication, whether mobile communication, television, internet, data, whatever it is, plus all the navigation related applications. Apart from that, still there are some of the other satellites. For example, the satellites that are meant for space science, where we have examples like Astrosat and Mangalyaan. So these are satellites which have been launched for space science research and exploration. So Astrosat, Mangalyaan, Chandrayaan 1, 2, and 3, Aditya L1 mission. So all these are examples of the satellites related to space science. Similarly, there are satellites which are called as experimental satellites, which are used in some kind of experiments. For example, INS 1A and 1B. Now, INS stands for ISRO Nano Satellite. That's why INS. So ISRO Nano Satellite. Now these are experimental satellites. These are experimental satellites. Now these satellites basically can be used for conducting various different types of experiments, whether space science related experiments, whether climate change related, space related, atmospheric studies, or even defense related experiments. We do have satellites meant for all these different purposes. So all these will be called as experimental satellites. Many a times it is just to test out a component, that there is an important component or a sensor that is supposed to be used in an upcoming mission. So before that we do all this test based on all these experimental satellites. So that's why we see that there are all these things that we can do. Then a very important bracket of satellites is small satellite. Now small satellites basically are satellites which are less than 500 kg. The satellites which have a mass of less than 500 kg, they are called as small satellites. Now, they also are subdivided into mini, micro, nano, and pico satellites. And there are even femto satellites not required. So, mini satellites basically are the satellites which have a mass in the range of 100 to 500 kg. Microsatellites, normally the ones that have the mass in the range of 20 to 100 kg, they are called as microsatellites. Nanosatellites, generally speaking, in the range of 1 to 20 kg, and picosatellites, the ones which are less than 1 kg. So in this manner, this is basically how we understand that there is a difference between all these different types of small satellites. Now, out of all these satellites, the most important bracket of satellites for us is nanosatellites. Today, you will see that there are many nanosatellites that are also being launched all across the world, and even including India. You will see that there are a lot of nanosatellites that we have been launching. So when it comes to the nanosatellites, always remember that these nanosatellites uh, basically become very important, and they have been gaining a lot of market because of a lot of different things. And this is where, I mean, something for your mains examination also, if they want, they can ask you a question from there. That, for example, let's say uh, it can be about, let's say, the importance of nanosatellites, or let's say the market of nanosatellites, that why is the market of nanosatellites developing or increasing. And just think of the points, you tell me the points and I'll give you the answer. If you miss something, I'll give you the answer, but you tell me, why do you think nanosatellites are becoming important? What is the importance of nanosatellites? So affordable, less money used. Look, let me write this as the first point, that they are low in cost. They are low in cost. What else? Easy to launch. Yes, they are easy to launch. What else? Less time consuming. Okay, that's good. Wonderful point. Less space debris, so less wastage. What else? Less fuel consumption. That's correct. Yeah, we can make it for, this can become specific purpose, so it can be launched for specific purpose and very in a very targeted manner. All right, it can be launched in a very targeted manner, so that's also correct. Now comes the second part. So until now, whatever points most of you have given, these are points related to the satellite itself. Now there are points related to its market also, that how exactly its market also develops. Now what we see is that with nano satellites, launches become easy. So that's why what then it does is that it also leads to a lot of private participation, leads to a lot of private participation and creates a lot of new employment opportunities. Creates a lot of employment opportunities. So a lot of employment opportunities, private participation will happen. New startups, they start to develop in this particular sector, and overall it becomes a very important source of revenue generation, very important source of revenue generation, especially for ISRO, because we see that it becomes very very crucial here. And you will see that there are examples. For example, let's say when we think of when we think of some of the launches that we have done in the past few years, especially let's say if we take the case of PSLV C37. PSLV C37. Now in PSLV C37, we launched 104 satellites in one single launch. 104 satellites, out of which 103 nano satellites were launched. 103 nano satellites plus one Cartosat satellite. So this was the breakdown of 104 satellites. 103 nano satellites had in one single launch, which became a world record, and it still holds as a world record. That there is no other country that has been able to do that. Before this, uh, the record was with Russia. They had launched 38 satellites in one single launch, and we launched 104 satellites in one single launch. The initial, I mean, the interesting fact here also is that initially the plan was not for 104 satellites. The plan was for 78 satellites to be launched in this launch. But then uh, we use this mode of transportation also in a very similar manner, how we use any other public transport mode. That, for example, the buses, the local trains, etc., would keep on filling until the time there is space. So same happened with ISRO also. ISRO said that, look, although the plan was for 78 satellites, but if there is somebody who needs to launch their satellite, you're most welcome to do so. So out of these 104 satellites, there were 101 foreign satellites, only 3 Indian satellites, one Cartosat satellite and two INS satellites, INS 1A and 1B. Apart from that, all the other satellites were foreign satellites. So that's why these kind of things does also help in revenue generation. It does help in revenue generation, because this is where we see that a lot of revenue can be generated with the help of these launches. And this is a low cost launch altogether. So that's why I was saying that it function in a very similar manner how our public transport system functions, that until the time there is a space for a speck of dust, people will keep filling up the buses and the trains. Similarly, we applied the same logic to our uh, launch also, where 104 satellites were launched in one single launch. So overall, we see that private companies, private players, private launches can be done. New startups come up, employment opportunities are generated, revenue generation can happen. And in this context, especially the role of something that we'll discuss later also, the role of NSIL, the role of NSIL, the role of in space, and the role of the SSLV launch vehicle, they should also be mentioned. If let's say there is anything, any question related to uh, nanosatellites, and we'll discuss about this. We'll discuss about what nanosatellites are, and sorry, I mean what SSLV is, what NSIL is, one what in space is. We'll discuss about all these things later. But for now, just remember that if at all a question comes, these are the things that you should mention, because we have seen that a lot of private players have started coming in, a lot of private participation has started happening. So for example, when PSLV C51 and PSLV C52 were launched, at that point of time, ISRO also had announced the fact that many of the parts that have been made, which have been used in this launch, they haven't been made all by only ISRO, but there is a company, Bharat Dynamics Limited. Bharat Dynamics Limited. This is the company that also helped, all right, in making these parts. So this is where the private participation also comes in. That we know that now all these things are also happening, and we see that more and more private players are also coming into the picture. And that's why, as soon as it happened, this was February 2022. And just look at the stock prices of Bharat Dynamics Limited. It used to be somewhere around rupees 200, 220, and today I think it is around 15, 1600, if not more. So this is how the change happened. Within a year, uh, the, the stock prices of Bharat Dynamics Limited skyrocketed, because every investor understood that this is a company that is doing well and also getting a lot of government projects. So read the current affairs to gain the knowledge in stock market as well. So we see that there are all these things that actually helps in all these scenario. Then lastly, we also have university or academic institution satellites. So these are satellites which have been produced or which have been designed by some college, some university, students and faculty. So Swayam, Pratham, all these kind of Kalam sat you might have heard of. So these are examples of student satellites, university or academic institution satellites. Now, these satellites also have a very important role to play, because whenever these satellites are constructed, the launch will be done by ISRO. The launch will be done by ISRO, and ISRO does not charge for these launches. If you have constructed a good satellite, the ISRO is more than willing to launch the satellite for you. And this is also something that makes, or maybe you can say, instills confidence in the students and increases the participation of the students, because then it will garner more interest in the students also, and more students will also start working towards this, and maybe they will also generate a lot of interest in space technology, that tomorrow even if they don't work with ISRO, at least they might work in space sector, and Indian space sector will grow because of that. So that's why it would help in the growth of space sector altogether. So that's why these satellites also become crucial. So look at this question. Uh, this was asked in your 2020 paper. There is one mistake here. If I tell you what the mistake is, I think you will tell me what the answer is. This should have been 3 only, and this should have been 1, 2, and 3. I don't think there is any point of launching a poll after this. But please read the question and let us just discuss this. Anyway, I'll launch the poll for you. Please mark your answers. Hmm. So 47% of you have marked D, which actually is the correct answer. So let me just discuss this with you. For measurement or estimation of which of the following are satellite images or remote sensing data used? First is chlorophyll content in the vegetation of a specific location. Now, can we calculate this? The answer is yes, we can calculate the chlorophyll content in the vegetation of a specific location. And how exactly can we do that? By measuring the intensity of green color. So green color intensity can be measured with the satellite pictures, and Earth observation satellites become useful here. And that's why in agriculture it will be helpful, because it will tell us about the health of agriculture, the health of vegetation, and whether we need to take certain steps to maintain the health of agriculture. So yes, this is something that is doable. Greenhouse gas emissions from rice paddies of a specific location. What kind of greenhouse gas emission happens from rice paddies? Which greenhouse gas? Any idea? Please tell me. Yes, correct. Methane. So methane gas emission happens. Correct. So now even this is measurable. How much of greenhouse gas emission happens? The estimations are done with the help of satellite images, with the help of the satellite observations. So that's why this is also doable. And then land surface temperature of a specific location. Now this is basically, when it comes to land surface temperature, we are looking for infrared rays. Largely it is about the measurement of infrared radiations or infrared rays, because they are associated with the heat, they are associated with higher temperature. So even this measurement is possible, this measurement is also possible. So that's why all these three things can be done with the help of satellite images. All these things can be done. And this question was actually asked in the context of a certain satellite called as HISIS, hyperspectral imaging satellite. Hyperspectral imaging satellite. This satellite was launched in 2019, and then the question was asked in 2020. So that's why this question actually came in the context of the HISIS satellite, because all these things can be done with the help of HISIS satellites, and hence this question was asked. Now let's stop our discussion here. We'll start with the discussion of Lagrange points in tomorrow's class. If you have any doubts, please let me know and let's discuss that, and then we shall end the class for today. Yeah, if you don't have any question, then you can leave. That's okay. Leaderboard, let me show the leaderboard. So Sakshi, you are the only one today who has given all the correct answers. That's wonderful. I'm not saying others have done bad. Uh, it's a good performance, but yes, getting all the correct is something else. Tomorrow is a holiday. Yes, tomorrow will be a holiday. The next class then will be on directly on Monday. Special case of GSO is GEO or vice versa? No. See, because all the parameters in geostationary orbits are fixed, that's why it is a special case. In case of geosynchronous has a more generalized structure to all the data. So that's why you will always say that geostationary is a special case of geosynchronous. How satellites revolve in elliptical shape? It is always use force to keep elliptical orbit. There are actually a lot of factors that we keep in check and take into account to ensure that it can be kept in that orbit. But I mean, it cannot be explained in one line. There are a lot of factors that come into the picture. Could you please share your UPSC journey experience, advice to crack 2024 UPSC? Advice, I mean, it's not a one line answer, but largely it is about your preparation, whether you have completed the syllabus completion being one, revision being two, and regular practice being three. These are three basic pillars to your preparation, so please make sure that you take care of this. Spy satellites placed in which orbit? There's no fixed orbit, but largely it is low earth orbit. Record of the highest number of satellites launched is already broken by SpaceX, which 143 satellites. Yeah, they have done that with the help, I mean, in the Starlink project. But there is a difference there. I'll discuss that with you. With regards to space debris, I'll discuss this point. Remote sensing means sensing remotely, meaning observing from a distance. Difference between polar and sun synchronous orbits. So the difference is not difference rather, but we would again say that sun synchronous is a special case of polar orbit. So in this particular scenario, what we are saying is that sun synchronous orbit, it is fixed that it will come over a certain point only 24 hours later. For normal polar orbits, it need not be fixed. Enough PPT class to study? I mean, yes, for all the static portions, as I've been telling, that everything that we do in the classroom plus the current affairs that we do for you, that should be enough. Will you be doing the news analysis today? Yes, I'll be doing the news analysis today. I've read the newspaper in the morning before coming to this classroom. Annotated PPTs are not uploaded. I'll just check with them once again. I'd ask them to upload it. Just if there is some kind of an issue, I'll check with them. Regular practice, in the sense, see, regular practice basically means that there are certain things that have been given to you for practicing. For example, right now the prelims test series is going on. So prelims test series, you have to be very vigilant with the current with the prelims test series. Always ensure that you revise and go to write that test, because when you do that, you will know where you are lacking, what you're doing good, what you're not able to do good. Then go through the analysis. A lot of questions that we do or give you in the prelims test series, we try to go beyond what we have just done in the classroom, so that we can add more topics to your preparation, and we can make this entire preparation journey more comprehensive. So that's why practice from all these sources, whether it is through daily questions, or let's say even there is a daily quiz that we conduct for you uh, in the evening, plus there are practice questions given to you from time to time, plus there is a PTS which is going on. So practicing from all these resources is very, very essential for one's preparation. The team has not shared the application of nuclear, as you were saying yesterday. Oh, sorry, it's my mistake, not theirs, because I did not share with them. I'll do that today. Difference between sun synchronous and geosynchronous, they are completely different. One is low earth, another one is high earth orbit. One is used for earth observation, other is used for communication purposes. So they are completely different. Difference of centripetal and centrifugal forces. Centripetal force is a force that acts, both the forces, they act in circular motion. Centripetal towards the center, centrifugal away from the center. Are you going to discuss Chandrayaan 3 and Aditya L1 mission? I'll probably discuss them more from the perspective of current affairs whenever current affairs classes are scheduled before the examination. But there will be some discussions that we will do, because even, for example, in Lagrange points, Aditya L1 discussion is supposed to come. So we'll discuss this. Take class which you have left earlier. Technically, yes, the extra class we will take it someday. I'll see when the it is being done, and we'll announce it accordingly. Prelims test series, where can you get? You can get it on the Byju's exam prep app. You can attend the class there, or if you are at one of our classroom centers, you can go to the classroom center also, and there also you can write the test. There are many online students, and there are a lot of tablet students also who are coming to the offline centers, and they attempt the test there. They come at the stipulated time of that center, and they actually attempt the paper there. So if you can do that, it will always be better instead of writing it at home. You don't have to enroll for offline test series. It's already a part of your course. Every student who is a part of the Byju's ecosystem, they you are, if you are at one of the offline centers, Delhi, Jaipur, and Lucknow in the north, Pune in west, you can say, and then Kolkata, and then in the south, Bangalore, Hyderabad, and Chennai. If you are in one of these centers, you can always go and write the test there. Schedule of the test series is there in your Byju's exam prep app. Please go through it. How geosynchronous satellites used to check greenhouse gases, not geosynchronous satellites, but rather the Earth observation satellites are used. And basically it's about the emissions. They do the spectrometry analysis of that, and they get the data with regards to how much of emissions are happening. In Bangalore, in Kormangla, can we attend the test series? Absolutely, you can. The prelims test series video was not available yesterday. Yes, there were some technical glitches because of which the faculty could not record it on time, and I think it is going to be available today. All right. So let's end the session here. If you have anything, please go back and revise everything. There are a lot of topics that we have covered here. So it needs a good revision from your end. If you have any doubts, you can always bring it back to us. And if you have any specific question for me, you can always also write to me at rasesh.kumar@byju's.com. Otherwise, you have the support emails also, islive@byju's.com. You can also write there. So let's end the session here. Let's meet back on Monday and we'll start with Lagrange points as our next topic. Thank you.